Now we're going to do integration by substitution part 2. First one we're going to look at is I need you to remember that when you were integrating a constant times e to the nice x dx, it was equal to its own antiderivative plus the constant of integration. Now the following problems are going to have e raised to an exponent other than the nice x, and we got to utilize the substitution process to integrate the problem. So as I scan through this problem, I see e, so e takes precedence. So whatever this exponent is going to be my u. So let's see if I did that. So u is equal to 6x squared minus 3x. Remember from the last part we went and got the derivative of du over dx, so this would be 12x minus 3. And then we had to solve for dx. So I would end up with du over 12x minus 3 equals dx. So now I'm going to put u in its place right here and this fraction in the dx position. And then let's see what we've got. Now hopefully you learned in the last part that if I'm changing this over to u, then x's have got to go away. They've got to eliminate. They've got to cancel. So this looks sort of suspicious right here. If I factor out a 3, that would leave me 4x minus 1. Notice that my 4x minus 1's would cancel. The 3 would go into negative 15 and negative 5 times. So let's see if I did that. I like canceling on this machine. It's so cool. But now I've got to write down what I've got left over. So I'm going to have the integral negative 5 e to the u times du. And now it's in the nice form. This is going to equal negative 5 e to the u plus my constant of integration. But remember, if I do substitution at the beginning, I've got to do it at the end. So I'm going to pull u down, what I let it be, and now I'm through with the problem. I'd like you to try the next problem, so I need you to pause me, and I'll go ahead and go through it. So once you're done, unpause me and see if we come up with the same answer. So looking at this problem, it looks like I need to let u be x to the third. Then du over dx would equal 3x squared. Solving for dx, I'd have du over 3x squared equals dx. So now doing my substitution, I'm going to have e to the u. I'm going to have the du over 3x squared. This still remains, but I need to cancel out my x squares. So now rewriting this, getting it in the correct form to see what I've got to do, that would give me the integral 1 over 3, notice the 3's in the denominator, e to the u times du. And I'm almost done because this is going to equal itself. So that's going to be 1/3 e to the u plus my constant of integration. And put what u was, x to the third, back in, and then I'm completely done with it. Cool. Not a bad problem. One more part. This is what I said, the integration by substitution part 2. Well, I've actually got 2 pieces here. This is the e. The next one I have to look at deals with an exponent of negative 1. Now remember that when I had an integral c over x dx equaled the integral c times x to the negative 1. Once I rewrote it, this equaled that constant times natural log of absolute value of x, whatever was attached to the negative 1 plus c. So the following problems contain the negative 1 exponent, but it's not just the x. So we're going to see how substitution process is going to help us integrate these problems. So first thing, I'm going to rewrite this, and it should look familiar. We've had to do things like this in the first part of this section. So I'm going to move the x cubed minus 3x plus 7 up, making it negative 1 exponent. And like what we learned before the e rule, I'm going to set whatever I've got in the parentheses here equal to u, the one that's raised to an exponent. So if it's raised to the negative 1, I'm playing the same game I did earlier. So this is u. Go find your du over dx. 3x squared minus 3. Solve for dx. I'm going to have du over 3x squared minus 3 equal dx. Now substitution. This first piece is left alone. Times u to the negative 1 times my fraction here that contains du. Looks suspicious. Factor out the 3. See where that gets me. Notice this factor and this factor cancels. So what I would have left over under this new box, I'm going to have the integral 1/3 u to the negative 1 times du. Now it's in this form that I had earlier. So I'm going to have 1/3 natural log of u, absolute value of u, plus the constant of integration. But doing my substitution, putting back in what u used to be, and there it is. Cool. Of course, I've got another problem that I want you to try. So pause me, and I'll get going on this. I'm going to move this to the numerator. -1 exponent. This is going to be u. So u is equal to t squared plus 3. du over dt, they changed variables on us, is going to equal 2t. Solving for dt, I'm going to have du over 2t equals dt. Substitute in. So the 2t carries down. This is now u, and I've got to put in what dt was. Ooh, notice the 2t's, they cancel. Lovely. So now all I've got is the integral u to the negative 1 du, which is automatically natural log of the absolute value of u plus c. And finish it up, pull what u was back down, and you're through with the problem. So you now got some problems to do. I believe in the next page on your packet there's just a whole bunch of problems to practice. The more you do, the better you get. Thank you. Bye-bye.